Hi, my name is Livy Bowers, and my project for Domesticating Bigness is creating spots of play through cooling, which is achieved by equitable commercial and social growth through thermal comfort. First, I want to direct you to Cedric Price's Fun Palace. This project looked at service duct systems and how they related to the main pedestrian levels. And Cedric Price's Archives was a project by Peter L.E. Lake, which looks at how waste exhaust air can be utilized to create an air curtain at Toronto City Hall. Price used these ideas of new technologies and combined them with the architectural form to create spaces that serve the public. This project does not have a building envelope, which encourages an open programming and an open audience. However, my project pushes the lack of an envelope and a lack of a building structure so that the outdoor environment becomes a place of play and comfort. Redlining's legacy plays a crucial role in the dynamic of extreme heat disproportionately affecting Black communities. Redlining refers to the discriminatory lending practices of the 1930s, which denied access to federally backed mortgages and loans to certain communities based on ethnicity and race. The Federal Homeowner Loan Corporation made maps and shaded red communities that it deemed hazardous, but that risk level was largely based on the amount of Black, Latin, Jewish, and immigrants living there. But redlining did not only deny Black communities the opportunity to purchase homes and build wealth, it also preyed on Black communities for the development of manufacturing facilities, waste plants, and highways, all of which are impervious surfaces that absorb heat, contributing to the urban heat island effect. With more pavement and less green space, previously redlined communities which are still predominantly Black are much hotter compared to other communities. There was a study of 108 urban areas nationwide. The formerly red-lined neighborhoods of nearly every city studied were hotter than non-red-lined neighborhoods, some by nearly 13 degrees. Many cities are not equipped with cooling infrastructure because they did not depend on it, but with the frequency and durability of heat waves growing, we need to look at equitable climate solutions. The urban heat island effect affects the built environment and the atmospheric environment. People lack thermal comfort, and in extreme heat waves, those who are most socially vulnerable are the most at risk. Heat and extreme heat waves have large effects socially, economically, and environmentally. There are different ways to employ passive or active and mechanical or non-mechanical systems to mitigate the effects of extreme heat. Evaporative cooling works through the idea of water evaporation through which the air is cooled down to a comfortable temperature, which is used in cooling and ventilation. One way of evaporating the air is through the use of fans. There are various technologies that exist that utilize fans operating at a range of speeds of air. The size and scale of fan speeds were used to develop the size and intensity matrix. Various machine precedents were used as a kit of parts for machine development, which resulted in the design of the 9 machines. Object 1A from the matrix is a small air hockey table diffuser. This machine uses the ideas of air diffusion that is used in air hockey tables. It ranks as one of the smaller machines operating at the lowest level of intensity. This is because of the subtle cooling effect from the diffusion surface. The machine operates with a fan on the back end and a duct that guides the air to be diffused evenly through the membrane of the air hockey table diffuser. The machine is supported by vertical structure and wires that support the lateral loads. Object 1B, the mist amplifier. It is a human-scale cooling device that uses a water tank and pump to supply mist and an intake duct to supply fresh air. The pump located inside the tank sends water up the pipe, which is then blasted by air coming from the intake duct above. The combination creates an evaporative cooling effect that is then hit by the outtake fan in the duct. The result is a medium intensity level of cooling. It operates at a scale of an average human's upper body. The amplifier is connected directly to the output fan in the duct. The intake fan directs air from above into the machine to be cooled. Object 1C. This is the double-ended cooling device. It is the last of the small-scale machines. It is a human-scaled cooling device that uses a piece of material as a cooling pad for evaporative cooling. This machine is dual directional, operating along the same axis. The 2 fans face in opposition to each other and blow onto the cool, wet material. The air hits the material and comes out the other end as an intense cooling sensation. The particles are diffused through the amplifier. Now looking at the animation, the amplifiers are attached at either end. The heavier loads on top of end of machine are supported by the structure, and the lateral loads are supported by the support wires. Object 2A, the overhead mist amplifier. This is a medium-scale cooling machine that uses a water tank and a pump to supply mist and an intake duct to supply fresh air. The cooling comes from above and creates a pleasant cooling environment below. The pump located within the tank supplies water to be misted. The mist is hit by the air from the intake fan and uses the ideas of evaporative cooling to create cooler air. The air is then directed downward by the outtake fan. This machine creates a cool environment that can be enjoyed by a few people below. There are many supports that hold the ducts within the external structure. The support wires help with the lateral loads. In the animation, we can see the pump located within the tank. Object 2B, the double-ended full-body cooling machine. This is a 12-fan operated vertical cooling device that uses evaporative cooling. This machine is dual-directional, operating along the same axis. The 12 fans face in opposition to each other and blow onto the wet material. The air hits the material and comes out the other end as an intense cooling sensation. This machine operates at the full human body scale in 2 directions. The amplifiers are stacked 3 high in 2 rows on either side. This object works well when grouped with a view of itself. It was designed with a repeatable nature. Object 2C, the small-scale fan-to-water amplifier. This is a cooling machine that utilizes water collection for evaporative cooling. It is the highest intensity level for the medium-scale machines. This machine has the ability to collect rainwater or pump water into the tank. The water is blown onto by a fan, and if the water is not cool enough for evaporative cooling, there are cooling pipes located within the tank that can act to cool the water. The cool air is then directed through the pipes and out one of the 4 amplifiers. The fans are located on the vertical edges of the tank and blow laterally and slightly down to hit the water and be amplified out into the environment. The water collection funnel is made of a waterproof material that directs the rainwater down. Object 3A, the overhead air hockey diffuser. It is a large-scale cooling device that uses the technology behind an air hockey table to diffuse air directed downwards. The air is supplied from intake ducts. These ducts also have the ability to be plugged into building systems. This machine was designed in a pair of 2 amplifiers. The coupling of the 2 amplifiers was so that it could stretch longer in one direction. This machine has a design where a few of them can be placed right next to each other to create a full area of diffused air. Object 3B, the fan joint. This machine is a dual fan system that uses 2 different fan sizes and amplifiers. This machine operates with seamless joining of 2 fans. The dual directionality of this fan makes it the most efficient operating at corners. The amplifiers have a 1-to-2 size relationship. The supports of this machine have to operate at each fan and amplifier scale. This creates interesting relationships in the structure. Object 3C, the large fan-to-water amplifier. This machine is the largest and with the highest level intensity. It operates with 12 amplifiers. With similar technology to the small fan-to-water amplifier, this machine takes the same ideas of rainwater collection and evaporative cooling. It differs in the number of amplifiers, size of the water tank, and it operates at a much higher fan speed. The fans are located on top of the tank and further away from the cooled audience. This allows for more noise control from the higher speed and intensity. The 9 machines have different zones of cooling and operate at a few different scales. Each machine can operate at a different range. There are some days where there is a higher moisture level and the misters can be turned off. New Orleans experiences extreme heat throughout the year, and many residents have been trying to use the technology they have to create cooler outdoor environments. Looking towards downtown and mid-city in New Orleans, there are many neighborhoods that were redlined in the 1930s. New Orleans is a city that greatly sees the effects of the urban heat island effect, with much higher temperatures in mid-city and downtown due to the lack of green space and many impervious surfaces. framing the hotspots with the areas that were historically redlined. Most of these hotspots are lined up to be in the historically redlined communities. So the site lies in Mid-City near Tulane Avenue, Canal Street, and bridges two historically redlined communities. The site is 1,600 feet by 3,200 feet. There were certain factors that were looked at that could trigger the need for a cooling machine or analyzed as an urban condition of the site. Public transportation stops, pedestrian crossing, lack or presence of a tree canopy, and predicted hotspots were considered urban triggers that call for a machine. Historic redlining and high population densities are urban conditions that were factored into the need for a machine as well. Each trigger or condition was mapped onto each other, and based off of the overlaps of the conditions, a different machine intensity level was assigned. Different urban triggers or conditions needed a different machine intensity. The overlaps in urban triggers or conditions could trigger multiple different levels of intensities. So there was another factor that helped determine the intensity level. This is whether the urban trigger has a harder or a more gradient edge condition. A more gradient edge condition makes that urban trigger or condition outweigh the other urban trigger's intensity level. Based on this analysis, the different intensity levels are plotted onto the site. Temperature data was collected on the site based on a radial or linear strategy. Radial data collection was used for smaller spaces, and linear was used for a larger space with no point of hierarchy. This could be large open spaces or walkways. The data was measured and then used to inform decisions about machine placement. The machine placement creates different types of spaces that can be used by the community. The small-scale objects help create communal backyard parks for small neighborhood communities. They are also used when there is a tree canopy to fit in with scale along busier streets. The medium-scale objects are used to transform hardscapes into communal parks and gardens. They create larger spaces for communal activity and thermal comfort. The large-scale objects also help in transforming hardscapes. They are also used at the urban scale to transform the spaces between buildings. Some have the ability to plug into existing infrastructure and blur the barriers between indoors and the outdoor environment. These spaces can be largely used by the public. There's a larger effect with all the objects placed together on the site to create all these different types of spaces for the community. Here's how the overhead air hockey table diffuser can be used as a plug-in into the buildings between spaces at the urban scale located above. And looking below at the repurposed hardscape, you can see different levels and intensities of machines being used. Looking at the full 1,600 feet by 3,200 feet site, the red pins mark the locations of the machines and are scaled based off the size and the intensity matrix. The first scene on the site is one of the backyard parks that can be used by the neighbors on that block for places of playing and community gathering. The medium and large scale machines are utilized in the scene to repurpose a hardscape into a communal park. The large-scale overhead air hockey table diffusers are plugged into the existing infrastructure in this urban campus. It creates gathering spaces for farmers markets or other activities between buildings. The machines can be used in locations with high pedestrian flow and at spots where people wait to cross the street. Thank you everyone for watching.